In this video, we're going to explain and solve the mathematical concept of quadratic equations. The quadratic formula has several uses and can be applied in real-life situations such as solving the speed of a moving object or the time taken for a ball to hit the ground. The general formula of the equation is ax squared plus bx plus c equals 0, where x is the variable and a, b, c are constants and a cannot be equal to 0. The quadratic formula is as shown here, where the plus and minus shows there can be two possible solutions as well as situations with one solution or none. Now where does this equation come from? Well, step 1, we divide the equation by a to get x squared alone. And then step 2, we use completing squares, which gives us that under the highlight in pink. From there, we just use LCM and solve for x, which finally gives us our quadratic formula.
The quadratic equation can be traced back to early Babylonia, Greece, Egypt, China, and India. In 300 BC, Euclid and Pythagoras developed methods to find quadratic solutions. However, this only gave one root. In 628 AD, Indian mathematician Brahmagupta derived the formula ax squared plus bx equals c. In the 7th century, proofs were found showing equations having two roots, the completing the square method, and that the discriminant must be positive. In 1238 AD, Yang Hui's work exhibited the first evidence of negative coefficients of x. In 1637, the formula recognized today was recorded.
The quadratic equation can be applied to real-life scenarios, such as solving for time. Consider the following. Leah shoots a basketball with the ball moving in the shape of a parabola. This is shown for the function h of t equals negative 0.5t squared plus 2.8t plus 9. To calculate the time taken for the ball to hit the ground if Leah misses his shot, let t be the time taken for the ball to reach the floor and h be the height of the ball before falling. We assume that the ball was shot at a parabolic path and that there is a sharp curve when the ball falls. Since we're finding the time taken for the ball to reach 0, the ground, we are finding the x-intercepts. Key assumptions regarding the parabola is that the maximum point is when the ball is in the air and the minimum is at x equals 0. To solve for time, substitute the constants a equals negative 0.5, b equals 2.8 and c equals 9 into the quadratic formula, which results in the equation shown. This simplifies to negative 2.28 and 7.88, where we can conclude that the time taken for the ball to reach the ground is 7.88 seconds, as we assume time can't be negative.
In this question, there are two speeds to think about. Let x be equal to the boat's speed in the water, let v be equal to the speed relative to the land, and the river flows downstream at 2 km per hour. We can turn those speeds into times by using time is equal to distance over speed. And we know the total time is 3 hours. Total time is equal to time upstream plus time downstream. Put all that together and solve it by using the quadratic formula where a, b, and c are from the quadratic equation in stand form. We got the answer. X is equal to minus 0.39 or 10.39. Because this is a real-world question, x can't be negative. The boat's speed will be 10.39 km per hour, and so the upstream journey will be 1.79 hours, and the downstream journey will be 1.21 hours.
Military uses. Using the quadratic equation, we're able to find firearm projectiles and landings. It is also possible to locate where artillery shells hit the ground. Evidently, this has social and political influences. Astronomical uses. The orbital cycles of planets were initially calculated using the quadratic equation to determine their orbit as elliptical as opposed to circular. Industry uses. Engineers interact with the quadratic equation frequently. For example, in the car industry, it can be used to determine the type of brakes required to stop vehicles traveling at different speeds. The equation is relevant for the construction of cars, trucks, motorcycles, and automobiles, and subsequently has a large social and environmental impact. Social policy creation. The formula can be utilized in determining the design and payment of pension plans and insurance packages.
We hope you enjoyed this podcast on quadratic equations and learnt more about its background, application, and use in everyday life.